So on any word problem where we need to create a system, we're pretty much always creating, especially on the problems on our test, we're creating an equation based on money and based on the number of items. Okay, so let's read through this and let's identify the important information. On this particular question, it says a class of students with some adults, parents, chaperones, and teachers went to the museum. A total of 36 tickets were purchased. Adult tickets cost $8, student tickets cost $5. The total amount of money spent on tickets was $231. So let's begin with creating an equation based on money. What's the important things when it comes to money? That adult tickets cost $8, that student tickets cost $5, and that we spent a total of $231. So I would actually write $8 for each adult ticket. So I would put 8A. And I know it's $5 for each student ticket, so 5S. And I know if I add whatever that amount is together, I will have my total amount of money spent, which is $231. Okay, so that is our first equation, an equation based on money. And now we're going to make a second equation based on number of items. Now, what do I mean by number of items? I'm not talking about potato chip bags. I'm not talking about fruit. I'm not talking about baskets during a basketball game. I am talking about tickets, right? Now, I don't know how many adult tickets were purchased. I don't know how many student tickets were purchased, but I know if I add them together, it'll give us the total of 36 tickets, because that's what the word problem tells us. So if I add them together, I will get equals 36. And that's a hard part, guys, creating your equation based on number of items, which is right there. We don't know how many adults, we don't know how many students, but we know that it's a total of 36 tickets. That's the number of items that we're talking about. So now we have that system. Now we need to combine and eliminate either the A's or the S's, and that is totally up to you. So what do you think would be good to cancel out, the A's or the S's? And you could go either route. Anybody? S's. Okay, so yeah, I would cancel out S's because it's pretty easy to get that bottom S to cancel with the top 5S. All I have to do is multiply by -5. So if I multiply by -5 and distribute, it'll give me an equation that'll have the S's be able to cancel out. So the top equation I'm not going to mess with. 8A plus 5S equals 231. The bottom equation, when I distribute -5 into all of those, it'll become -5A minus 5S equals -5 times 36. What is that? -5 times 30 is -150. -5 times 6 is 30. -30. -150 and -30 is -180. I did distributed property in my head. Of course, you could use a calculator. Now that the lines are ready to combine and eliminate those S's, we will have 3 A's. 8 take away 5 is 3, equaling, what is 231 take away 180? Let's ask Siri. Hey Siri, what is 231 take away 180? And that did not work. I don't know why.
(231 minus 180 is 51.
There you go. It worked. 51. Okay. So we have a 51 right here. So we have a simple one-step equation here that we're going to divide by 3, divide by 3. That cancels out. A equals 17, I believe. Yeah, use a calculator to double check that. But we now know that the number of adult tickets were 17. There were 17 adults that went on this field trip, okay? Now, maybe the question is asking how many adults went on this trip. And if that were the question, then you would be done. But the actual question, if we read up here, how many students went on this trip? So they don't really care about the adults. All they want is students. So we need to continue solving. Take this 17, plug it in. If there were 17 adults, how many students were needed to get a total of 36? So I'm just going to substitute 17 plus S equaling 36. I'm going to subtract 17, S equals, that is 19. So there were a total of 19 students on this trip. So on Friday's test, you're going to have to type in, sometimes you type in the coordinate, sometimes you type in, but right here they're just simply asking how many students went. So all you got to do is type in 19, hit enter, you're done. Okay, if you type in 17, it's going to be incorrect. Now, on the other hand, maybe the question Friday will say how many adults went on this trip. Then yeah, type in 17, hit enter, and you're done. Sound good? Let's take a look at another word problem. This one's a little different. Vaughn sells a bag of fruit that has 12 total apples and oranges. It has 12 pieces of fruit, right, of apples and oranges. Each apple costs $1.75. Each orange costs 75 cents. The total cost of the bag is $14. How many oranges are in the bag? Well, once again, we're going to create two equations. One equation is going to be based on money. The other equation is going to be based on the number of items. So if you're dealing with money, yeah, you're going to have to create an equation based on money. So here we go. Let's jot down everything that's important with regards to money. We have apples costing $1.75. Oranges costing 75 cents. And the total cost for the bag of fruit is $14. So let's start by writing down each of those apples will be $1.75. So $1.75 times however many apples, that'll give me the amount of money that the apples cost. And we're going to add that with the 75 cents for each orange, the 0.75 for each orange. Big giant O for orange, so you don't think it's a zero. And we know that when we add those two amounts together, we're going to get the total cost of the bag, which is $14. Now you could put 14.00 if you want, or you could just leave it 14, whatever. So that is an equation based on money. 1.75A plus 0.750 equals $14, 14.00. Now we're going to create an equation based on the number of items. Now we are not talking about baskets at a basketball game. We are not talking about bags of chips. We are not talking about tickets. Right here we're talking about fruit, right? And I don't know how many apples, I don't know how many oranges, but I know that the total amount of fruit in this bag, if we look up here back to the word problem, it says it has 12 total apples and oranges. So I know that if I add the A plus the O, I will get 12 total pieces of fruit in my bag. So it's that easy, guys. You got to read it carefully, create one equation based on money. There it is. Create another equation based on the number of items, whatever you're dealing with. It might be fruit, it might be baskets at a basketball game, it might be bags of potato chips, right? Depends on the number. Tickets at a museum, I don't know. Right here we're dealing with fruit. Apples plus oranges equals the total amount of apples and oranges in the bag, which is 12. So I hope we understand. That's the hard part, creating the system. Now, the easy part's actually solving it. So we want to solve this thing. You might want to use substitution, or you might want to get rid of those decimals, right? You could move a decimal one place to the right by multiplying by 10. You can move a decimal 2 places to the right by multiplying by 100. And that's exactly what I'm going to do. I'm going to take this top equation and multiply it by 100. If I multiply it by 100, it'll simply move it over and make it 175 apples. It'll make it 75 oranges, and it'll make it 1,400 instead of 14. So let's do that. Multiply everything by 100, and that will give us up here 175A plus 75O, big O, equals 1,400. So this is my new modified equation by multiplying everything by 100. I did that to get rid of decimals. Now the bottom equation, obviously I'm going to have to multiply that bottom equation by something to get either the A's to cancel or the oranges to cancel. So what do you think would be easier to cancel? The A's by multiplying the whole bottom equation by negative 175, or cancel out the oranges by multiplying the whole bottom equation by negative 75? Wait, multiply this. If you want to cancel out the A's, you're going to have to multiply everything by negative 175. If you want to cancel out the O's, all you got to do is multiply by negative 75. So which is it going to be? Cancel out apples or oranges? What do you say? Totally up to you. There's a weird silence here. All you guys got to do is tell me oranges or apples.
Apples.
Okay, you want to cancel out apples, so you want to multiply everything by 175. Yeah? Okay, so if we do that, let's multiply everything by 175. I probably would have canceled out oranges. I'd rather multiply by 75 instead of 175, but you guys said apples. Let's cancel out apples by multiplying by negative 175. So I will get negative 175 apples. I will get negative 175 oranges. And I will get, I don't know what 175 times 12 is. Hey Siri, what is 175 times 12?
175 times 12 is 2,100.
2,100, Siri says. So we have negative 2,100. Because a negative times a positive is a negative. So now that we've modified both equations, we could combine. The apples cancel. We end up with negative 100 of these oranges. I want to put it in yellow so it doesn't look like 1,000. Equals 1,400 take away 2,100. That'll be a negative 700. Okay, so your equation is negative 100 O equals negative 700. Divide both sides by negative 100, and you will get the amount of oranges is really positive 7. So that's not a 0. Yeah, maybe I should do this. Let me replace that with saying just oranges. The number of oranges is 7. Okay, the number of oranges is 7. So if they ask for oranges, you just type in 7. How many oranges are in the bag? Type in 7, hit enter, you're done. If it says how many apples are in the bag, then you have to plug it in to find out how many apples are in the bag, which is pretty simple. If there are 7 oranges, then there must be 5 apples in order to get a total of 12. What are they asking on this problem? They are asking how many oranges are in the bag. We know how many oranges there are. There are 7. So type in 7, hit enter, you're done. I hope that makes sense. It's really not that bad. The more you practice, the easier it gets. You do have plenty of homework to practice, so please do that. Now, there's one more section in Chapter 6 that we need to cover today, but it's really nothing new. Now, what do I mean by nothing new? We have graphed inequalities before, right? You guys remember this? How do we graph? It's still the same thing. Y equals mx plus b. It crosses at 4. And from that point, I need to rise and run according to my m, which is 2. So up 2 over 1, and I'll be off the graph. So if I go up 2 over 1, I'm off the graph. So let me use that pattern, but backwards. Over 1, down 2, over 1, down 2. Put a dot right here. Let me do it in red, though. And then continue to go over 1, down 2. And you could extend the line as far as you want. Now the question is, do I draw a solid line or a dotted line? That is based on your inequality. If you have a solid line underneath the inequality, it will be solid. If you do not have a solid line underneath the inequality, it won't be a solid line. Does that make sense? You guys remember that? Okay, so this is definitely going to be a dotted line. So let's put some dots between the dots. And then one other thing about inequalities, it's talking about an area of answers. So your answers are either going to be above the red dotted line or below the red dotted line. One option to figure that out is to test a point like 0, 0, which is clearly below, on the lower right side of that red dotted line. If 0, 0 works, then it is a solution. That means that all your solutions are on this side. If 0, 0 doesn't work, it's not an answer. That means that all your answers are on the other side. Okay? Now, there is a shortcut. Instead of doing this math, if you have y by itself, which we do, we know that y runs up and down, and this inequality says y is less than. So what does that mean? Less than with regards to up and down. Where's less than? Is it up there or is it down there? It's obviously down there. So the shortcut would be, if y is by itself and this is a less than, you will shade below. So just shade below that red dotted line, and that shading represents all the answers that work for that inequality. So if I were to test 0, 0, it's in the shaded area, I know it'll work. It will be a solution because all the solutions are here in this shaded area. If I plug in a 0 there and a 0 there, 0 is less than 0 plus 4. Yes, 0 is less than 4. It's a true statement. That works. Any point down here works. No point up here works. all right? Let's try another one. This one over here crosses at 1, so let's put a dot at 1. My slope is up 1 over 1, so you go up 1 over 1. You could continue to go up 1 over 1 and do the same pattern but backwards to extend it in the other direction. And then you're like, is this a solid line or a dotted line? This is definitely solid because it has a solid line underneath your inequality. So I'm going to draw a solid line through those dots. I can't leave it dotted, it has to be solid. Now, in addition to that, I need to shade in where my answers are at. They're either going to be above or below. And we could use the shortcut because y is by itself. Y is running up and down. And this says y is greater than or equal to. The or equal to part we already dealt with by making it solid. But greater than means above. So we're going to shade in everything above on the line. So up here. Any point on that shaded area is my solution. Any point on the other side is not a solution. So we've already done this in the past. The only thing new today is that we are solving systems of inequalities. Now, solving systems of inequalities, it sounds crazy, but it's really just doing what we just did, two different inequalities on the same graph, okay? So it is really that easy. Check this out. I am going to graph the above inequality in red. So that guy crosses the y-axis at 3. 1, 2, 3. From that point, my slope is up 1 over 1, right there and right there. Let me do it in red. And I could use this pattern backwards to extend it all the way across the graph that they give me. And not only that, I need to decide if it's a solid line or a dotted line. What do you guys say, solid or dotted? Anybody awake? Solid or dotted? All right. Thanks for making it awkward. Hey, thank you finally. Thank you. Thank you for responding. Thank you, Jaylene. Thank you, Camila. It is dotted because it does not have a solid line underneath it. So let's put some dots between those dots. And then we need to shade either above or below. The shortcut is y is by itself. You could think of y, which is up and down, saying y is greater. Where's greater? Greater is up here. So anything above that red dotted line is your answer. That's where we're shading in. So please shade in everything above the red dotted line. So I now need to graph this inequality on the same graph. That's the only difference. We've already been graphing inequalities, but the only difference, I'm going to be graphing two of them on the same graph. So this guy, y equals mx plus b, technically it doesn't have an m. It's like y and a number. It crosses the y-axis right here. It has no m, which means the m is 0, which means it's totally flat. Or you could remember this. If you just have y and a number, go to your y-axis, go to the number, do a flat line right through it. If it's x equals a number, go to your x, go to that number, and draw a vertical line right through it. That was a shortcut that we learned also a long time ago in semester 1 on graphing. So right here, y is less than or equal to -1. I know my line is flat, no slope, it's crossing right through here. And I know that it's also solid because it has a solid line underneath that inequality. And I should be graphing this in blue. I don't know why I'm using red, I'm sorry. But anyways, we do know it's a solid line. There it is, solid. And we need to shade in above or below. Let's use a shortcut. Y is less than or equal to. We already dealt with the equal to part. That's a solid line. Less than is below. It's down here on the Y. So let's shade in everything down here on the Y. I mean on the Y, on the blue line. So the real solution is where your overlap piece is. When we think about solving a basic system of equations, you graph one line, you graph the other line. What's the answer? It's the point that they share. But right here, you're graphing one area and you're graphing another area. What's the answer? It's the area that they share. It's the overlap piece. So I'm going to shade it in right here in yellow. So technically, anything in that yellow triangle is the solution. What does that mean? I could pick any coordinate, like the coordinate -1, 2, 3, 4, 5, 6, -1, 2. I could pick the coordinate -6, +2, and plug it into x and y, and it will work for both. And only in this area, in this triangle, well, technically it's infinite because it's way over here also. Any coordinate over here in this area will satisfy the system. So this is the solution to that system of inequalities. So we're really, truly not doing anything new. All we're doing is graphing two inequalities on the same graph and recognizing that their overlap piece is the answer, okay? Let's try another. Let's try number 5 right here. These are not ready to graph. They're in standard form. I need them in slope-intercept form, which is really easy to do. Let's just get that x over to the other side. Let me rewrite it. Y is less than or equal to -x minus 1. That's ready to graph now. It crosses at -1. From that point, I go down 1 over 1, down 1 over 1. I could use the pattern backwards to extend the line as far as I want. And I know it's going to be a solid line because the inequality has a solid line. So I'm going to draw a solid line right through those dots. And now I either need to shade in above that red solid line or below that red solid line. What do you guys say, above or below? See how y is by itself? We're talking about y's that are up and down. Where's less than? Is up here less than, or is down here less than? Obviously down there is less than, below. So we're going to shade in everything below that red solid line. Any point down there will be a solution to the top equation in red, inequality in red. Let's do the same for the bottom inequality. Let's get it ready to graph. Subtract x, you will have y is greater than or equal to, write the x first and the +3 second. Now it's in y equals mx plus b. We graph it, it crosses at -3, or at +3, 1, 2, 3. Whoops, that's not 3, up here, 3. And then we're gonna go down 1 over 1 because the slope, the m value is -1 over 1. Continue that pattern all the way down, use that pattern backwards. This one will be a solid line because it has a solid line underneath the inequality. So this is a solid line right here. And now we need to either shade in above that blue solid line or below that blue solid line. And we should all conclude that because this is a greater than, that would mean above. So we're going to shade in above the blue solid line. Now, where are your solutions at? It's the area that they share. So what could you conclude from this graph? What is the solution to this system of inequalities? What do we say? What do we write as our final answer? Our final answer is that there is no answer. There is no solution because there is no overlap on the areas of the highlighted portions. Does that make sense? I hope so. All right. So that's what we're doing. And like I said, it's nothing new. So you need to practice. If you have a printer, then you might as well print this worksheet and do it. If you don't have a printer, please watch the video that's already been uploaded. Let's do one more. Why not? This one's ready to rock. It should be pretty easy. It says y is greater than x plus 1. Okay, crosses at 1. My slope is +1, so I go up 1 over 1, up 1 over 1. And then you can use that pattern backwards. Really easy to graph. We learned this in semester 1. We know it's not going to be a solid line because it does not have a solid line underneath it. So I'm going to leave it like that. I'm going to put more dots between the dots. And then I either need a shade above this red dotted line or below this red dotted line. And if we look at the inequality, it says greater than, y is greater than. Greater than on the y is above. So I'm going to shade in everything that's above. Okay, now let's graph the other one in blue. This one says y is greater than or equal to -x plus 1. That one crosses the y-axis at +1, the same exact location. But instead of my slope being up 1 over 1, it's negative. So down 1 over 1 and put a dot right there. Down 1 over 1, down 1 over 1. Use that pattern backwards to extend it in the other direction. This one right here will be a solid line because it has a solid line underneath it. So this one will be a solid line. All we have to do now is graph or shade either below that blue solid line or above that blue solid line. What do you guys say? Above the blue or below the blue? Because it says y is greater than or equal to, greater than is above on the y. So we're going to shade in above that blue solid line. So the question is, where is your overlap piece? And the overlap piece would be this triangle right here, this red dotted side, this blue solid side, and the triangle, everything in between those two, right? So any coordinate within that yellow triangle will be a solution to the above system of inequalities. So ladies and gentlemen, I will leave you at that. All you need to do is practice. If you don't have a printer, just watch the videos that I upload and you'll be good to go. Tomorrow, we're just going to review all kinds of solving systems, substitution, linear combinations. We're going to review some vocab, consistent independent, inconsistent, consistent dependent. We're going to just review all types of solving systems, and we'll be ready for our test on Friday.